Good morning, students. Today we start unit number 1, that is water analysis, treatments and industrial application. As we are aware that water is the most widely used and abundant chemical, and its main sources are rainwater, river water and lake water, wells and springs. Further, it is also categorized as surface water and groundwater. Water contain different type of dissolved salts, particularly calcium ion, magnesium ion, and a small amount of iron, aluminum, and strontium. The presence of these type of metals or the elements in water considered as water not suitable for producing enough leather with soap, that is hard water. The unit of hardness are ppm, parts per million, milligram per liter, degree Clark, degree French. So presence of calcium and magnesium ion in a small amount of iron, aluminum and strontium is known as hard water. There are two characteristics or properties we will discuss in our syllabus. One is hardness of water, second is alkalinity of water. Hardness in water is due to the presence of bicarbonates, chlorides, and sulfates of calcium, magnesium, and a small amount of iron, aluminum, and strontium. This term was applied to water which consume a lot of soap without producing leather and was thus hard to wash in. The Ca2 plus calcium and Mg2 plus magnesium ions in water form insoluble salts with soap, which is essentially sodium stearate. On the other hand, alkalinity of a sample of water is due to the presence of OH negative ion, SCO3 negative ion, and CO3 2 negative ion. They are hydroxide ion, bicarbonate ion, and carbonate ion. So combination of these ions are also responsible for alkalinity of water. One combination OH negative and SO3 negative does not exist because they will form CO3 2 negative in water. We have to analyze different constituents in water. They are calcium hardness, magnesium hardness, sodium hardness also known as pseudo hardness, bicarbonate alkalinity, carbonate alkalinity, hydroxide alkalinity and acidity. The table shows interrelationship between different units of hardness. They are ppm, grains per gallon, degree Clark, degree French, and degree German. We are aware that 1 ppm is equal to or equivalent to 1 milligram per liter, equivalent to 0.058 grains per gallon, 0.07 degree Clark, 0.10 degree French, and 0.56 degree German. In our syllabus of engineering chemistry practical, we have two experiment related to unit number 1. They are determination of the total hardness of given water sample and determination of alkalinity. So first we discuss determination of alkalinity of given water sample, in which we want to determine presence of calcium, magnesium ion and small amount of iron, aluminum and strontium ion in the unknown water sample. So first of all we take standard hard water, and using standard hard water, we standardized EDTA solution. EDTA full form is ethylene diamine tetraacetate. We require water sample, burette, pipette, funnel, flask, dropper, measuring cylinder. And reagents, we require EDTA, Iriochrome black tea indicator, ammonia buffer 10 pH, and distilled water. In the following manner, we will prepare different reagents, that is EDTA, Iriochrome black tea, ammonia buffer. First step in the procedure, we start with filling the burette with EDTA solution up to zero level. Then we pipette out 50 ml of standard hard water. Then add 1 ml of buffer solution. We add indicator few drops, and initially violet color appears. On titrating with acid, it changes to blue color. In this way, we repeat the experiment minimum 3 times, in which last two reading must be concurrent. In the same manner, we have to titrate the unknown hard water also, and we get two different reading, one for the standard hard water and other for the unknown hard water. Now, using the formula, we will determine temporary hardness and permanent hardness and total hardness of given water sample. Here, the conical flask shows different color, violet at the initial point and blue color at the end point. So this is some information about how we determine hardness of given water sample using EDTA titration or complexometric titration method. Next we have experiment determination of the alkalinity of given water sample. Here also we require volumetric analysis, that is titration. In this we are using any acid HCl or H2SO4 as titrant. The alkalinity of water is the measure or the capacity to neutralize the acid. In this we want to determine presence of HCO3 ion, that is bicarbonate ion, CO3 2 negative ion, that is carbonate ion, and OH negative ion, that is hydroxide ion in the water. So for this experiment we take any acid, fill it onto the burette, then we pipette out a non-water sample, then titrate it with HCl. Before titrating, we add small drop or few drop of phenolphthalein. Pink color appears. Then after titration, this pink color disappears. That is recorded as phenolphthalein endpoint. Now in the same solution or the flask, we add few drop of methyl orange indicator. Here the color appear yellow. On titrating with HCl or H2SO for any acid, it changes to red color. So we repeat the experiment for phenolphthalein endpoint 3 times minimum, or till the concurrent reading appears, and for the methyl orange endpoint till the concurrent readings appear. After that, we will calculate total alkalinity of a given water sample using the calculation, in which we add both values for phenolphthalein endpoint and methyl orange endpoint. Now this diagram shows a different type of hardness. When the hardness value of water is 0 to 60 ppm, that is parts per million, it is termed as soft water. When the value is between 60 to 120 ppm, it is known as moderate hard water. When the value is 120 to 180 ppm, it is known as hard water. More than 180 ppm water is termed as very hard water, not suitable for industrial use as well as for drinking or domestic use. Now, on the other hand, this pH scale shows more than 7 pH is water is known as alkaline water, and as we are aware that alkalinity is because of presence of OH negative ion, CO3 2 negative ion, and SCO3 negative ion. So this is some basic information about water and its characteristics and impurity, that is presence of hardness and alkalinity in the water sample. Thanks.